Hi, very good morning. So let us go to the second lecture of the feedback amplifiers. So let's discuss the current series feedback amplifier. Now, as the name indicates series, so what we are going to do is we are going to take the voltage and we are going to subtract it from the source. From the source is this one. Now, this is a current series feedback amplifier. Now, in this case, if you see, the current is I out, right? So output is current and input is voltage. Now let me say you this point. So we generally say the amplifier is like output by input. Now in my case the output is current, input is voltage, so this is like 1 by R, and we can say it as the conductance, right, G. So this is the concept we are going to see. So in my case the amplifier, the output is I out and the input is V. So this is what is okay. Now let us apply the same concept to this. Now what are all the things I'm going to get from this? The first thing that I'm going to get is like GM, that is like I naught divided by V in. Then next one is I'm going to calculate VGMF, that is like the gain with feedback. So that is I out divided by Vf. And then next is beta. When I say beta, this is the output and input is this one. So beta value is always V of divided by I out. And then next one what we are going to see is like IRIF, that is the input impedance with feedback. Then we'll see IR out F or ROF, that is the output with the feedback. Now these are all the things that we are going to derive. Now let me start deriving these things. So now I know that the Vs is equal to like Vi plus Vf. Now in this case what I'll do is Vi value, Vi is equal to Vs minus Vf. Now what I'll do is instead of this one, I'll write it as Vs minus feedback value is like beta times I out. I'll write it. So now what is this I out? I out is like if you see, there is Gm times Vi. So I'll write it as Vs minus beta into this value, right? Gm times Vi. So that's equal to Vi. Now let me group the Vi terms. So Vi 1 plus this I'm bringing here, beta times Gm Vi, that's equal to Vs. Then what I'll do is I'll take this as I out by Gm into 1 plus beta Gm times Vi, that's equal to Vs. Now I out I'll take it out, so Vs divided by I out, so this we have brought in, so that is 1 we have brought is like 1 plus Vs and then I out, so this is going to be Gm times Vi divided by Gm. Now I need I out by Vs, that's what is my interest, right? I out by Vs, so I out by Vs, so that's going to be Gm divided by 1 plus beta times Gm Vi. So this is the gain, that is like we'll say GMF, that is the gain with the feedback. Now let's go ahead and solve for the input impedance and output impedance. Okay, now input impedance, now input impedance is what I'm going to calculate is RIF. RIF is like Vs divided by II, right? Vs divided by II or the input voltage. Now in this again we are going to give the same process. Vi is equal to Vs minus Vf. Now let me take it this way. So Vi is equal to Vs minus, instead of Vf, I'll write it as beta times I naught. Now I'll write it as Vs minus, instead of I naught, I'll write it as Gm times Vi. So this is I out, so this is also like this. Now let us group the Vi terms together. So Vi is equal to 1 plus beta Gm times Vi. So that's going to be like a Vs. So instead of Vi, I'll write it as Ii into Ri into 1 plus beta times Gm Vi. That's equal to Vs. Now what I need is RIF. RIF value is like this Vs divided by, I'll take it as II. So what is left out is Ri times 1 plus beta Gm into Vi, right? So if we check this, the input impedance has increased, right? Now let's do the same for output impedance. Now output impedance, if I write, so output impedance, again we're going to say in the same formula. First is make Vs is equal to 0, right? And then replace RL by a voltage source. Now if I take to the circuit, now what I'm going to do is I'm going to remove this RL and I'm going to introduce a voltage source, right? So let me go down to this and let me draw the circuit, that is Gm times Vi. That's like R out here, and I have replaced that by a voltage source V. So this is the voltage source that we are giving in. Now again the same process follows here. I'm having like well, Vi is equal to Vs minus Vf, that we already know. The Vs value is made equal to 0, so Vi is equal to minus Vf. So now I'm giving the voltage here and I say that some current is moving like this. The current I is flowing through it. Now if I write so minus Vf value, let me come. So it's going to be like minus beta times I, right? Now let's go ahead. Now the current I is getting divided into two branches. One is like this and other one is like this. So I value is equal to, so voltage is this voltage divided by R out. So that is the current flowing this way, and this current is like, it's in the opposite direction, right? So it is minus Gm times Vi. So this one we have. Right now what I'll do is I'll write it as V by R out minus Gm. Instead of Vi, I'll write it as minus beta times I naught. So now based on this, if I write, so it's going to be V by R out plus Gm beta I out. So I'll use the term I out here. So it's going to be like this way. So now based on this, I'll write I is equal, I'll take this, yeah, I is equal to V by R out minus Gm times I. The reason is pretty simple, because the direction of the I and I out, say this is I we are getting, so I out is in the opposite direction. Why it has to be in the opposite direction? Let me take you to this part. See here, the I out is here, right? So we are taking that part and bringing it here, right? So I'm going to write like this, minus I. So if I do that, so we will get this as V by R out is equal to I 1 plus Gm, right? I think I missed the beta value. Yeah, it's beta here. Then this is beta. So V by R out. So that is what is the output impedance. So that is like, so if I want to find R out F, so that is going to be V by I into R out into 1 plus Gm times beta. So what did I do? I brought this down, I took it up, So I get this value. So overall, if you see for this, the input impedance is also increased, the output impedance is also increased. Now just a briefing of what we have seen now. So here if you see that the gain is this much, right, GMF, and then the input impedance has increased and the output impedance is also increased, right? Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.